All right, here is the third and final subsection, I guess, of proportions that I want to talk about. In the previous two subsections, we talked about probability, so kind of using the normal CDF function in our calculator. And then we talked about confidence intervals, so it was the one prop z interval function you used on your calculator. What I want to do in this section is deal with hypothesis testing. And just like I did in the previous two sections, I want to leverage what you learned the first time through this to kind of teach it the second time through it. So the first time through, we were dealing with means as opposed to proportions. We were dealing with numeric data as opposed to what's called binary categorical data. And when we had numeric data and we could talk about means with hypothesis testing, we were always given a sample mean and this kind of baseline population mean that we called mu naught. And we kind of compared x bar and mu naught to see if we can make inferences about the differences between mu and mu naught. There are these three different notions of average, and we really had to be comfortable with these three to understand what we were doing with hypothesis testing. Well, guess what? This second time around, it's going to be pretty similar. There's still going to be three different notions that we're interested in. One of them will deal with the sample, and two of them will deal with populations. However, they couldn't possibly be sample means and population means because our data is binary categorical. It's not numeric, so it doesn't make sense to use the word mean. But if we change the word mean to the word proportion, pretty much everything will be the same. So what I'm saying is this next time around with hypothesis testing, we can do hypothesis testing. It's just not hypothesis testing with means. It's hypothesis testing with proportions. And there'll be three symbols that you're especially interested in, three different notions of proportion as opposed to mean. There'll be a sample proportion. In the past, what we've been using for sample proportion is p hat. I've told you to kind of tie together in your head what we used to call x bar with what we're now calling p hat. That's still valid. We'll be given a sample proportion. And the symbol for that is still p hat. And we will be given a population baseline, not mean, but proportion. We used to call that mu naught. Wouldn't make sense to call it mu naught because it's not a mu anymore, it's a p. So how about p naught? We'll be given a sample proportion p hat and a population baseline proportion. And the symbol for that will be p naught. And we'll be asked about, well, let's see, what would make the most sense? Last time we were asked about the population mean mu. So I guess it would make the most sense if we were asked about the population proportion. What symbol should we use for population proportion? Well, the population proportion, we've been calling it P, and I've told you to tie that P and that mu together in your head. So instead of mu, we're going to call P. And maybe I should have mentioned this third one second, so then I could be like, well, what do you think we should call mu naught? P naught would make the most sense. At any rate, when we're doing hypothesis testing with proportions, the ideas will be pretty similar to when we did them with means, except instead of x bar, mu naught, and mu, we'll have p hat, p naught, and p. If you think back to hypothesis testing, it was always a four-step process. State your null and alternative hypotheses. Those always compared together mu and mu naught. Guess what? In this section, you're going to be stating your null and alternative hypotheses. And what do you want them to compare together? To make this as logical as possible, as easy on you, what would you like them to compare together? Hopefully your answer is I would like them to compare together p and p naught, because those are the new versions of mu and mu naught, and that's exactly what they're going to do. You always state your null and alternative. They'll always compare together p and p naught. Then you'll always state your shape, your center, and your spread. Best case scenario is if they're really similar to this shape, center, and spread that we've been using in 4.5. Guess what they are? Then you're going to draw your picture. Oh, right. When we used to draw the pictures the first time around, it kind of depended. We learned the classical method of hypothesis testing and the p-value method of hypothesis testing. And with the classical method, we needed a critical value and a test statistic, and we had to see if our test statistic was in the rejection region. Guess what? Same thing. Dealing with proportions, you could still use the classical method or the p-value method. And if it's the classical method, you're still going to have a critical value so you know where your rejection region starts. And you'll see if your test statistic's in your rejection region. If it's the p-value method you used to compare your p-value to alpha, you still do. It's still comparing your p-value to alpha. This is very, very similar to the last time we did this. It's just the symbols are different. And that causes a lot of angst for students. They don't like these new symbols. They barely understood it the first time through when we use these symbols. But if you can get a good grasp on 4.3, you'll find that this 4.5 stuff isn't that bad. Your conclusions. Last time I made this big deal about there's only two possible conclusions, right? Either you reject the null and say the claim is true, or you can't reject the null, so you can't say that the claim is true. Same thing here. I promise it's the exact same thing we'll be doing here as we did there. Last time we decided to reject the null if the test statistic was in the rejection region or if the p-value was less than alpha, depending on whether we're using the classical method or the p-value method. It's the exact same criteria. When you state your conclusion, you will say, because the test statistic's in the rejection region, there is sufficient evidence to reject the null hypothesis, and therefore I can conclude that whatever the claim is true. I think that rather than go into an example on this video, because I don't want the example videos to be super long, maybe I'll call that good. We'll just have a really short intro to hypothesis testing with proportions, and then I'll make a few videos with examples, and then we'll be done with this section.